Class, we're back. And what I'd like you to do is to take out the question sheets that you got today. There were three of them. Now, these here are the question sheets with the answers. So obviously, it saves a lot of time on giving you the answers. So let's take a look at them. Now, we've talked about some of these before, so we're not going to spend too much time on them, but some we have not. So we'll talk about those. All right, let's do number 27. What's a globe valve? Now, a globe valve, let's just read this together. It's got a washer and a seat, does not have a full waterway. It's used as a stop and waste. Now, how can you tell what a full waterway is? Very simple. Open up the valve. This is obviously not connected to anything. And look inside. If you can't see out the other side, it's probably going to be a globe valve. They're very inexpensive. Stop and waste, for example. Uh, R19, R14, those are all examples of a globe valve. However, they are very restrictive. As a result, you can't use them on water service coming into a building. They can be used anywhere in the water system, but not at the service. Do not use one at the water service. Name three things that are a detriment to the plumbing system. Poor venting or no venting. Obviously, you don't have to explain that. Example. I don't know if I told you this. I think I did. Maybe I didn't. I don't think I told both groups, but I did have a job once in Little Compton before I was an inspector. So it was back in the '80s, early '80s. It was a let's see, what kind of house was that? It was a modular house. It wasn't a manufactured house, by the way, is another name for a trailer, what we call a house trailer. That's a manufactured home. A modular home is exactly what you've heard. It's made at a factory, typically a place like Pennsylvania, and it comes in two halves over the road to the foundation that was prepared in advance. Occasionally, you'll have one of those houses with four of those units, two down, two up, and maybe even one to the side, like a family room. But most of them are like a ranch house, two sides. They put together on the foundation. They tie up the roof. Usually, the roof is laying down, and they bring it up and tie it up. I understand they can do it in a day, maybe two. And unless you know what you're looking at, you wouldn't even realize it was a modular home. There is a wall down the middle that's quite thick because it's like double 2x4s put together, and there's some trim they put in. But the guys that do this, are fast, and like I said, they can bang it out in not much more than a day. Now, how does that affect us? We end up with a house. You walk in the basement, and the pipes are all cut off a few inches below the floor, and each one of them is labeled clearly: lav, water closet, tub, whatever it is. You could probably figure it out for yourself, but it's all well marked. And you have to take them, put them together, and take them over to the septic system. Now, in the city, obviously, you take it over to wherever the city sewer was going to exit the building. And you just follow the code. Now, the depending on the city or town, because of some bad luck that some cities and towns have had with pipes being separated in the wall, they don't just let them go unless there's some very recent changes. Particular certain cities and towns require you to like pull the toilet, pull a disconnect tub like in the basement, and cap everything and fill the stack. Obviously, this is not something you would have planned on. You would just plan on doing the plumbing in the basement, try all your drains, everything's good. See you later. But this would require a lot of extra time. Now, I've done a number of modular homes, but I suspect that all mine came before these these codes came about. I think the last one I did was that one in Little Compton. That would have been about 1985. So I believe all of the more recent rulings are city and town laws uh, that have changed that came about because of problem. I know it came about because of problems, and the factories that put these together are they do their own inspections. So I can imagine they don't inspect too closely. And there's like one guy in a huge factory spot checking. Not every one, so I've been told. And when they come here, In the past, they were like automatically passed by the state. And so what we do is just hook up what's in the basement. Anyway, I'm getting off the track here. But the only example of what happens without a vent or with a vent in the same house is this house that I'm telling you about. I hooked everything up, and I know I've told this story to at least probably to you too. Bear with me. Um, and hooked all my drains up. Had no leaks. You know, everything's draining down. It was before you had to cap everything. Drains are swirling around, draining slowly. The toilet's not flushing well, like it was partially blocked. So I didn't know what was wrong. Went in the basement, and I had a clean out down there. Obviously, on the before it went out of the building, and I popped the cover off, and I could hear air like rushing in and water coming down all of a sudden. What the hell? I didn't know what it was. So I did some more investigating. I went up in the attic. Now the attic was like a, I guess it was like a truss roof, but it was a ranch house, so the roof was not that high. It was maybe, I don't think you could stand straight up, but it was high enough to get into. So I went up there and I went over to see the stack, not knowing what I'm looking for. I looked at everything else, and there it was. And what I had was this. Here's the roof. Instead of going like this and then out the roof like that, this pipe here was like that. Okay? They forgot to support it over here. It wasn't quite sagging that much, but it was sagging more than the diameter of the pipe. So what happened is this filled up like a trap, and it prevented any air from getting from here into here. Now, going over the road, it just settled in the flashing, right? The rubber flashing. Didn't leak. No, the flashing caved in, but it still didn't leak. And what I did was to lift this pipe up so it looked like it did before I erased it. So I lifted it up like this. And when I did, I broke a seal right here, one of the glue joints, like, oh, so it was no big deal. But the water went down the drain, went down into the stack. So I realized that what happened was the same as if you did this. You put a cap on it up here, right? So if you guys that have filled up a stack and you have multiple stacks, some of them will say in addition, they're lower down because it's just coming out one floor. And then you got the main house, 2 floors high. The lower one has to be capped. Otherwise, the water will never get any higher than the lowest stack. So this had the same effect of putting a cap up here, like a gym cap on the end of it, or an inflatable, whatever. So when I took that, when I did this, right, the water all went down the drain, and I went downstairs, checked the fixtures, everything was fine. So the example I'm trying to make here is that if your vents are non-existent, in this case, the whole house had no vent, things don't work. And another example would be, if you remember when you were a kid, things are getting a little bit slow. You put your finger over the straw, take it over, let it go on your brother, right? And whatever was in the straw comes out because it was caught up in like a vacuum. Uh, I'm not going to tell you to do this if you're not getting paid, but yeah, it's a thought. But just a cap on the vent, especially the main vent, and you're going to create all kinds of hell inside. Okay, enough of that. Let's see. We got to find the globe valve. We went from globe valve to this here. All right, name 3 things we. All right, we did that. Oh, venting and poor venting. All right, that did apply. Number 29. What's the minimum size battery loop? Now, I think we did battery loop tier 2. You gotta hold off on this stuff here. It's coming later. Okay, a battery loop. Very quick. If I didn't cover it with, I think tier 1, I'll just do it real quick. Let's say we have some toilets lined up in a commercial bathroom. We'll say there's 3 toilets. It would look like this, all floor mounted, all coming into the same line. Okay, that's a battery vent. 2 or more fixtures on the same level, usually a toilet. And we'll say there's a stack here. And this would be the battery vent. The vent would be between the last 2. So this line here would be 4-inch. Remember, 3 toilets on one level, got to go to 4-inch. So you get a 4-inch line, which means the vent has to be half that size. So you get a 2-inch vent. Okay. That's in what, 1 minute. That was how you do battery venting. Obviously, we got to do that again some other time. All right, but that's what a battery vent is. Almost always commercial. I think maybe once I've seen a residential setup where I could actually put a battery vent between two toilets. Okay, minimum size battery loop and battery circuit vent. All right, the answer is inch and a quarter. The vent would be inch and a quarter, and you'd have two-inch floor drains. I use two water closets, but if you had two floor drains, just like I had it drawn, between them you put a vent and a 2-inch pipe. The minimum vent size would be inch and a quarter. We never use it, but the book says half the drain size, but not less than inch and a quarter. So it's more of a book answer, but remember it. And the most battery fixtures you can put on are 8, and it does say that right here, between the last two. Now, what happens if you got 9 or 10 fixtures? You count out 1, 2, 3, 4, 5, 6, 7, put a vent at 7, between 7 and 8, and then start again. So if you had 3 more, you'd put one between the last two. All right, so every 8, you put one in between, like the 7th and the 8th. Okay, now the next one, number 30, is a big deal, very big deal, and I didn't make this sheet. This was one I inherited somewhere along my time, and I like this one a lot because there's a whole lot of questions here that might be asked for your license. Now let's start with water freezing and boiling. Now this is one of the rare times where they talk about centigrade, Celsius, and Fahrenheit, because all of our temperatures, unless I tell you otherwise, are always Fahrenheit. Fortunately for us, we didn't go that route. Now, our friends in the automotive trade, I'm sure you know some of them, they're stuck. They got what do they call them, SAE. They got the tools that are the metric size, and then they got the standard size, the inch tools, like we have. So they're always switching back and forth, but we don't. Fortunately, our trade has stayed pretty much away from the centigrade metric. Okay, water freezes. Remember these. I think everybody here knows it freezes at 32, and which is 0 centigrade, and it boils at 212. Now, the freezing, of course, would be, that would go to our water piping, like in a basement. So if you got a cellar or storage area that's borderline, be careful. You might want to look into some insulation, heat tape, something. And at the other end, we got water boiling. That's not so much for plumbing, but for heating. And you get water that's up around 212, you're pushing it. We try to keep our heating systems operating around 180, 200. Okay. Uh, that's a good temperature. That your baseboard is set up for for 185 degrees is what it's rated for. So now let's say that you're cheap and you're competing on a job, and if you crank up the temperature of the water, you get a little more output on the baseboard. You might get yourself, instead of 600 BTUs per foot, you might jack it up to maybe 650. Okay, I'm making up the number. But you'd have to raise the temperature. So you raise the temperature, so it's now 190, 210. Okay, now the pressure on the water is, pressure reducer knocks it down to, I believe it's 15 to 18 pounds. It usually runs a little higher, it runs around 20. And that's enough to keep it from boiling. But you don't want to go over boiling where you're relying on the pressure to hold that from boiling. I have seen a boiler boil. It sounds like a tea kettle. It was malfunctioning. I didn't realize it right away. I thought it was just some excess air. And fortunately, I saw it before anything got out of hand. And the let me see, the relief valve didn't trip. The float air vent was whistling like it, just exactly like the whistle on a tea kettle, like your grandmother's tea kettle. It was whistling away. It can be dangerous, so stay away from that. Go with the recommended 180, 200 if that's the manufacturer's recommendation, and don't try to, slide in a cheaper boiler, a smaller boiler, so you can jack up the temperature. Here's another thing: if you do that, you don't have any backup. You can't raise the temperature to adjust for a boiler that was undersized. Maybe they add a room or something. You don't have much to work with there, right? If you're already at the absolute limit on that boiler by raising the temperature, you're kind of limited. Okay, um, let's get back down to water at its densest. I don't think that's spelled right, but it's not a word you see very often. It's Dense and ist. Maybe it is. I don't know. I'm not pretty good at spelling, but I could be wrong about that. But anyway, that very immaterial. Okay, so what this means is, let's say you're in a laboratory and you had water in a container, a very accurate container. We'll say it was exactly 1 quart, and at we'll say room temperature, and you cooled it very slowly. The water would actually shrink, just like hot water expands. That's why we have expansion tanks and everything we do. The water starts to contract. It gets smaller and smaller. And when does it get to the point where takes up the least amount of space? We'll say it takes up 98% of the space that it did at 70 degrees. That temperature is 39 degrees. Now, according to uh, the book, if you drop below 39 degrees, the water starts to expand again very slowly. Then when you hit 32, we know what happens there. It turns to ice and it expands greatly. That's when you start losing your pipes. But the answer for the book, for your license, is 39 degrees. Not something that most people would know. In fact, probably nobody knows that. But it pops up for license questions. Now, the next number we have to deal with, this is getting back into the real world, 110. The word I'd like you to highlight here, you might even want to underline, is public restroom. This doesn't apply to private homes. Strictly a public restroom. So you're doing a job in a commercial building of some kind and open to the public, a business. The plumbing inspector could come in and take his thermometer out and test the water temperature. In fact, he'd be smart if he did, because if he passes it and somebody gets hurt, burned, or whatever, they're going to come back at both the inspector and you, and maybe the manufacturer. That's another story. So remember that 110, commercial or public restroom, hot water, right? Now the next one, 112. Okay, another big one for us, especially if you do houses. This is the maximum temperature out of shower head. Okay, that's it, just the shower head. Now let's say this tub has the big Roman spout with the big handles, big fancy tub in a platform dropped in. That doesn't apply. That's 130, like everything else in the house. But if you want a tub like that and you want a shower, well, I remember doing, and some of you guys have probably done it, you use like a Simmons valve on the back wall, and then you have a handheld shower that you can hook up, put on a hook, and maybe use it as a shower. Well, you gotta be careful because that kind of bathtub it's dropped in and it has a ledge, and the water can easily go outside it. But if you want to put any kind of shower head, even a handheld, it's got to be one that's designed to be at 112. And I have had an inspector test that on me. First time I saw that, I almost passed out. The guy pulls out a thermometer, kind of like a pen type, puts it under the water, and it was off a couple of degrees. And he showed me on a Simmons. This was many, many years ago. He showed me how to adjust the. I should have known, but I didn't. He showed me. He said, "Here's how you adjust the Simmons." And there's a set screw, and you turn it till you got your 112, and then you lock it, hit that screw, and then after that, the handle will never turn past that point. Now, most of you probably already know this. Now, for you rookies that haven't been out there long, remember, an inspector will be looking for that. Now, it might be something that your boss might take care of, or maybe he never did, and nobody's ever called him on it. But these valves are adjustable, and 112 is the number that you need to know because it's a very common question for your license. Now, the next number is another big one. Hottest water in the house, 130. Okay, except the shower head. Now, the only water that's hotter than that is in the dishwasher. It goes in hot, 130 or so, and then it kicks it up. And everybody here who's ever opened a door of a dishwasher when it got done and latched onto a plate, you don't forget, you don't make that mistake twice. That's not 130. I don't know how hot it is, but it's a lot more than 130. Okay, but 130 is the limit. Now, the next one, 150, could be worded a little bit better. 150 is the hottest water that you put into the sewer, right? If you go much hotter than that, you're going to start working over your PVC pipes, right? You really don't want to do that. Boiling water, not a good idea, right? PVC doesn't like that. I have seen PVC right alongside a steam boiler. It went around the steam boiler. Just the heat from the boiler caused this 1.25 inch sump pump line. It was PVC to drop 90 degrees. It made an arc down like this. Then there was an elbow, and it came up again without leaking. It was amazing. It had a giant trap. I don't think there was any water in it because the sump pump was only there as a backup, as you know, for safety, and that was a dry cellar. Okay, so remember that these numbers here, even though 2 or 3 of them are very important, the rest of them are like only good for a test. So the hottest water you can put down the drain, 150, and on hot water for sterilization, this would be commercial. This would be 180. Okay, so remember that. Now, what I have on this, if anybody noticed that you're wondering what's this all about. Okay, this one here is, according to about a year ago, I checked on this, and this stuff is still popping up on the code apparently. So I had this one in my time. This was around, and I guess it's still there. So let's take a look. Let's say you want to go, you have the Celsius, and you want to go to Fahrenheit. Okay, let me show you a trick. This one I learned a long time ago. If Fahrenheit equals 60 degrees, right? C equals 15. Okay? Remember, no, I'm sorry. I don't know why I keep doing that. It's not that 60. It's pretty good though. 59 isn't bad. If F is 59, C is 15. Okay, or the other way around. If you got the Celsius is 15, F is 59. It gets a little tricky when you get down around 0 or minus, but we're not going to go there. All right, so let's just stay on the positive side here. Remember these two. So what I did is to show you an example using these two. So if you're taking a test and they're asking you to go from Fahrenheit to Celsius, Celsius to Fahrenheit, this is your test. Try your formula with 15 and 59 and make sure that it works. I just did this before I came on the screen here. I had to work. Actually, I had to work this one out. This one came easy. This one here, I had to practice, had to do a couple, but it worked out. Eventually, I got where I wanted because I knew that this here, if this one here, if F equals 60, find C. Okay, so F here, right there, 59, and the answer is 15. Okay, so let's run through it. Now, I know some of this stuff is not too exciting, but this one is less exciting than even some of that other stuff. But let's look at it quick. All right, so here's what I'd like you to do. If you want to copy this down or just save it, not a bad idea. You can work a few of your own problems. All right, so let's try this. If C is 15, find F. Here's the formula. Write it like this. F equals C, 15, times 1.8. 1.8 is just one of those fixed things like pi or one of those other things. 15 times 1.8, right? It's 27 plus 32. All right, 27 and 32, 59. Done. Now that's the proof if you're going to use slightly different formula. Hold on a second. I'll check the time. 2:07. Damn. Okay, I just realized that I didn't write the time down. Okay, I'm afraid this might go over because I don't know where we are for time. All right, let's do another 10 minutes. Okay, so if you do the math out, you can substitute your own numbers. Now, what's going to happen is, unless you do these two numbers here, one of these is going to come out like a fraction or a decimal. Okay, that's the problem. That's why I like these two, because it's the only two numbers that I'm aware of that land exactly on even numbers. Okay, you can prove that. Make this like 16. Yeah, you can make that 16 up here, but the f is going to be not going to be like two numbers more. It'll be 59 or maybe 61 point something. It's going to be a decimal or whatever. Now, this will prove that if you go from f, you're looking for f. This is the formula. Now on this one here, if I gave you the f, right here, c, that's what you're looking for, equals f equals. I'm sorry, keep putting 60. It's 59. All right. So what do we have? 59 minus 32 is 27 divided by 1.8 equals 15. That's it. Okay, it's like, middle school math. The math part is easy. The problem is you got to remember the formula. So remember how to do that, right? Even if you can only remember this one, you can figure this one out, right? It's like the reverse. And then do the problem that they're asking. Now with a calculator, it's very easy, but you got to have the formula right. Okay, the last one on that page was minimum age for an apprentice is 16. All right, next page. Page 5. How many apprentices can a master have if there are 6 journeyman plumbers? Okay, I think we've covered this one, but let's go over it. 1 per, right? The master is kind of like an umbrella, and he's like the umbrella. Let's get rid of this. Now remember, as a master, you can only have 1 apprentice. So it looked like this. Here's your master. He's got 1 apprentice. Now, if he wants to go into business, he can do this. He could have, in this case here, I'm going to give him 4 journeymen. And under each journeyman, I can put an apprentice like this. Okay, very simple. This guy here, though, legally, now let's look at that book question. He can have 6 journeymen. If there's 6 journeymen, how many can he have? He can have 1 for himself, so he can have 7. 1 for himself and 1 for each in his employ. All right, what they're not saying here is that this guy has to be supervised 40 hours a week by either not one of these guys, because they're already tied up with one of their own apprentice. So unless one of these guys doesn't show up, he can't work with these journeymen, right? He can only work with a master. Now, most master plumbers, they're not going to be working with the tools for 40 hours. We know that. They're going to be running the business. I mean, these businesses don't run themselves. Chasing money, setting up jobs, talking to customers, whatever. So this is a little iffy. The book doesn't, technically, that's the book answer. You got 4 journeymen, so you got 4 apprentices, plus 1 for the master. That's it. All right. What does Section 6 in the Plumbing Code say concerning advertisement? All right, this we have not covered, but let's mention it right now. In the ad that you run by a master or journeyman, you must contain your name, designation. Designation would be like MP or JP, and your license number. Okay? So in my case, it would be like MP 9009. Would I put my journeyman down there too? I never did put it on my car truck when I had a truck. A lot of guys do. They'll have both, but they're not saying it here. I would put my MP 9009. I don't think anybody would be complaining about that. Okay, 35. What's the chapter and heading of the Plumbing and Gas Code? All right, this is strictly a test question. 248, Code of Mass Regulations, Section 1-7, Mass Uniform Plumbing and Gas Code. CMR means Commonwealth of Mass Regulations. Okay, they don't really tell you that very often, but here it is. What was good, it was where these questions came from that put it in there. Okay, next one, number 36. Shifting gears, they're all over the place here. Hoar frost, HOAR. This is frost that collects at the top of a vent pipe in cold weather and blocks off the vent. You got hot, wet, moist air coming up from an appliance, a fixture In theory, it could block with frost. Um, Maybe it would be snow and ice coming into it. Who knows? So that's why going out the roof, we have a 2 inch minimum pipe size. Now, I did read once that when venting was being designed back in the mid 1800s, I think it was, they realized that you only had to put a very small vent to relieve the pressure, so it wouldn't create a vacuum. Good example, the old gasoline cans, the kind you can't buy anymore. Do you remember that second cap? That hole was tiny. It was like a little bigger than a BB hole, but that's all you needed. With the cap on, the water would glug, or gasoline would glug out. If it was uncapped, that little tiny hole was enough to let the air in. Um, the problem is that the pipe, the 2 inch going out the roof, is more than adequate, but they don't want it to freeze. So that's why they have the 2 inch minimum pipe size. All right. Number 37. What's the agency that administers the plumbing and gas codes? The Board of State Examiners and the plumbing and gas fitters. All right. There's only one board. It's got one guy that runs it. Chairman of the, I think he's chairman of the board, and all the inspectors know who it is because they meet. I guess they meet with him. I never inspected a mass, so I'm not that familiar with it. And now this one here, I don't know that you have to memorize these principles of plumbing. I know I went over it in the book. It's the very beginning. I think it's about page 80. It's page 81 to be exact, and it only runs for about 2 pages, and it's a summary of the entire book. I can't believe that they would ask you specifically which principles, what they are. But according to this here, maybe they do. It's something you could look into. What does Principle 1 say in the code? State in the code. All occupied premises shall have potable water. It says portable there. Cross that R out. It's not portable. Portable means you can carry it. It's not. Potable, Potable. That means water that's fit to drink, bathe, cook, and all that stuff. What does Principle 3 state in the code? Hot water is required for all fixtures that take it. Okay, not worded too well. What it's saying there is any fixture that you have that needs hot water in a sink, hot water in a bathtub, for example, then it has to be, you have to supply hot water. Ever go into an old fashioned gas station? There's still a few around. I bumped into one earlier this year, actually. You go in and it's got cold water, but the hot water is not even connected or it doesn't work. And nobody, it's been like that probably 50 years. Nobody's bothering them. But according to the book, if you install a fixture and it needs hot water, hook it up. Excuse me. All right. Number 40. What does principle number 6 state? The required plumbing fixtures are. All right. And this one here is the obvious ones. You got a bathroom, you got a toilet, sink, and a tub or shower, and a kitchen sink, and a laundry facility. Laundry facility means a connection, um, a drain, and a hot and cold hookup. Okay. That's it. Every house has to have that at a minimum. What must a plumber do to operate a business in a town? Okay, here it is. You register with the Board of Health in that town or whatever agency is, they might have the town clerk or whoever handles it in that town. But that is true. You do have to register. I remember doing that many, many years ago, and it hasn't changed. And this one here, again, we're all over the map on the questions. 42. The height required for a water test on a sanitary drain is a 10-foot head. Uh, a better way, I think, to word that is, uh, what kind of test do you put on some underground piping? A test that involves a 10-foot head of water, right? Now, for those of you who haven't done it, you just cap all the pipe that you're putting underground. It's all exposed so it can be inspected. And then you have maybe a 2-inch pipe, and you brace it so it doesn't fall over, whether it's no hub with a gasket or a piece of PVC, if it's some kind of residential. And you brace it so it doesn't fall over. Fill it up with a hose, right? You can fill it up from it down below, or just put the hose in the top. And the inspector will check it out, and he has the right to tell you, I want to see the water come out the top. So you're going to have the water hooked up. Turn the water on, water comes out the 10-foot pipe. Okay, he's happy. And he looks around, makes sure no water leaking out of the joints. That's the 10-foot head they're talking about. Now, I am not sure when I started. I'm going to do just a few more minutes here, and we'll call it a night. Okay, here it is. We just talked about this one. Where in plumbing is a permit not required? One place is changing a washer. Okay, and then getting into incorporation, um, you got to obviously got to file some paperwork. Now, when would you incorporate? This one here, I would talk to your accountant. If you got a buddy that's a lawyer, so they don't charge you a fortune, you could check with them. But mostly your accountant would probably tell you. My guess is that you're just a one or two man shop. You're probably not going to incorporate, but you can, and it just requires that you keep like a separate set of books, and it costs some money. But obviously, most big businesses are, as we all know, are corporations at some point, right? When you get big enough, you pretty much have to become a corporation so that you're not personally responsible for everything that goes on. The corporation itself becomes like a legal person. Now, pressure and water pipe. Again, we're jumping around here. What's the pressure on a water pipe? What do you test it to? This is your hot and cold. Okay, here it is, 125 pounds. And they don't mention it here. I don't think it's popping up, but I believe it's 15 minutes. You could do it with water. You can do it with the air. I remember one time I borrowed my uncle's, I think it was nitrogen. It was like, oh man, it was back in the late 70s when I first went in business. And I know you guys that have used air, you turn the air on, and hopefully you've got a compressor that can handle 125. When I did this nitrogen, just the needle went from zero like to over 100 in like 2 seconds. I couldn't believe how much pressure was in these tanks. Very convenient, but if I remember right, the tank was heavy and you had to rent it. So unless you're doing a lot of work, I don't know if that's worth it. Okay, so that could be water or air, or in that case, nitrogen, but it's a 125-pound test. Minimum time required for a plumbing job to be inspected. It's another important one. The inspector has 48 hours or 2 business days. If he doesn't make it, and doesn't include the weekend, it says it right there, or holiday. If he doesn't make it in 2 days, don't cover it up. Bad move. He's wrong by not getting out there. But don't be a wise guy. Call him back. Ask him. A lot of guys will say, oh, geez, I got busy. I couldn't make it. You're all set. Or I'll get there today. But the book does say 48 hours or 2 business days. Minimum pitch on 4-inch pipe. We've done this many times. 1/8 inch per foot minimum. Usually it's quarter, but minimum is 8. Which of the following fitting is legal? Okay, I'm going to stop right here because I don't have time to go through all these illegal ones. So I'm going to make a mark on this. This is where we ended, number 48. Okay, so put the rest of this page aside, and let's see. I thought we had one more. Let me take a little closer look here. Yeah, we do. Oh, I didn't realize it. We already covered them. Okay, so we've done page 4, page 5. And this page 6, we're going to stop right there. So we ended with 47. We'll pick it up on 48. Okay, guys, see you back in class.